Hello everyone. In this video, we are going to discuss the hollowing of a model and the cutting of a model. Many users have asked the question, I want to make a very big model. Should I cut it first and then hollow the parts, or should I hollow it first and then cut the parts? I would recommend, first of all, hollowing it first and then do the cutting. Otherwise, if you end up with 50 to 100 part STL, you have to do the hollow one by one, which is tedious. So definitely hollowing a model first and then cutting it. Then we come to the second problem that many users have encountered, which is when they hollow the model, they've seen defects, or they didn't see the defects immediately, but when they cut the hollow model, there are defects. I will take model first. This is a dark model, free from defects, and I'm going to do cutting. Apologies, I'm going to do hollowing. I will use the default 10. Many users did not pay attention to the size of the original model and just clicked OK without changing the default value. This is okay for this model because the original model is 80 in Z direction. It is about 100 in the X direction, and it is about 60 in the Y direction. So that kind of size is okay for a wall thickness of 10. STL has no unit, so you can think of this unit as millimeter. If you think of this as inch, centimeter, or even meter, all the numbers here are attached to that unit. So the 10 should be a reasonable scale for the original model. If it is too big, for example, 100, the model size is barely 100, and if you input a wall thickness of 100, the model cannot be hollowed because it cannot be hollowed to a wall thickness of 100. 10 is fine. Let's click OK. The hollowing function takes some time to calculate an inner surface, and then it will generate a new window it is still calculating, not responding. Now it's here. So this is the original dark with hollowed. That is only a title. In order to see the hollow model better, you can use the clipping tool. It can clip inside. Okay. And if you look at the original dark, you can clip inside, and there is nothing inside. It is a solid model. This is a hollow model. So the original size of an STL may not be the size that you want to make it big. For example, the original size here is 80 millimeter in Z direction. What if you want to make it 800 millimeter in Z direction and then cut it up into smaller pieces? Should you cut it or hollow it? As we discussed earlier, you need to hollow it first. But what is the wall thickness? If you hollow it based on the size of 80, then it's not intuitive that what is the actual wall thickness that's going to turn out to be if you use the default value 10. So before hollowing, if you are dealing with a model that will be resized, I recommend you first use object transform to resize the model to the final size before hollowing it. So the original size is 70.2. Let's say we want to make it 800 millimeter as the final size. Click OK. I will close this one because this one you can see the wall thickness is very big. Then we use hollow. Recall that this is already the final size, 800 millimeter. Then I'm going to use maybe 15 millimeter as the wall thickness. And LuBan is calculating the inner surface of the model. Takes a little while, but I believe the inner surface will be much thinner than the previous example. It's coming out. Okay, let's clip into the model. That is a fairly thin wall thickness. Still, it is 15 millimeter because the overall scale is much bigger. Now we can cut it, and I'll use modular cut, and I'm going to leave all this as default. So I set the printer size to be fairly small, 200, 150, and 140. To simplify all these kind of things, I'll just use whatever that is here that is reasonable. Cut it. It has been cut into probably 50 or more parts, so it will take a while to calculate. Done. The easiest way to visualize this hollow model that has been cut is to use Object Explode. You can click keyboard shortcut E several times to explode more. As you can see, it is all hollowed, and the panel you get is only on the surface. There is nothing inside. Several users have encountered problem that after they cut it, they can see something in the middle, or they see triangles, dangling triangles in the model. Those are artifacts, and the artifacts are usually introduced when you hollow the model. In the next example, we are going to show you how some artifacts could be introduced. This model has no defect, therefore all the parts looks reasonable. Okay, we have 174 parts. Close this guy. This is the hollow model. Oh, that's the solid model. Okay. So in which scenario the artifact might be introduced? First, of course, the original model is defective. Then after you hollow it, there will still be defects. And then when you cut a defective model, you get defects as well. The second scenario that you will end up with defective model is when you hollow it. You have used a wall thickness that is fairly small. This is 800 millimeter in height, and we have seen how thin a wall thickness of 15 millimeter. But in this case, let's say I created a wall thickness of 2 millimeter. Click OK. In principle, it is okay to create a hollow model of wall thickness only 2 millimeter. But in practice, if the wall thickness is very small, the inner surface may intersect the outer surface at high curvature regions. Let's see if we are lucky or not on this example. Oh, of course we are not lucky. You can already see some inner surface coming out at the high curvature regions. They come out by showing the dark spot because the inner surface is bright inside and dark on the exterior. So the exterior is already exposed on the surface, on the outer surface. That means now you have a typical defect called self-intersection. This is a model with self-intersection. The outer surface intersects the inner surface. When you cut this model, you will get a lot of defects. Let's give it a go. Oh, wait, cancel. I should have clicked cutting, not LuBan. Cut. In order to reduce the amount of calculation, I'm going to increase my printer size. Okay, we don't need to have that many cuts in order to see the defects. Cutting is done. Superficially, there is no defect, but if we press E, there is still no defect. Oh my god, we got lucky today. I mean, there is no obvious defect because I suspect the defect is on the edge. And in this case, in this example, the edge is too thin, so we don't see any defect. Anyway, this is not a good example. So if the cutting lines goes through this exposed region, there should be defects. So let me reduce the printer size to have it cut into more parts. Then I think we definitely have some cutting lines going across these defective regions. Okay, you see? Now you see the defects. And we have several users reporting that when they cut a hollow model, the cut parts turn out to be solid. There's everything inside. There shouldn't be. It should be hollow model. That is due to the defects. It has cut through a region where the inner surface intersects the outer surface, and it has confused the algorithm. So you end up with all these blocks that shouldn't be there. This is typical, okay? For example, this one. That block shouldn't even be there because it's inside. Okay, go back to the, all right. So this example demonstrated when you have a hollow model with defects, and when you cut it, you may end up with a solid model. That is caused by the defect in the hollow model. That has covered 90% of what I wanted to say in this video. Before we finish, I'm going to open up another example to quickly show you the steps to follow through. The first step to follow through before you do hollowing and cutting is to check the size, the dimension of the original model. This model is pretty small. When you check the dimension using mesh statistics, you will see that the x is 7.0, y is 21.7, z is 13.3, whichever unit that is. That could be millimeter, centimeter, meter. It's up to you to determine the size. So remember this dimension. And when you click Mesh Hollow, the wall thickness that you input needs to be in the same unit. And obviously 10 is not suitable for this model. 10 is too big. If you click 10, you might get a warning saying failed to hollow the model. So the right way is to go to Object, Transform, and set the final size you want to print the model. I want to print it 5 millimeter in height. Click OK. And then go to Mesh Hollow. Now we know that the z direction is 500. By the way, the model's origin is not 0, 0, 0, but something negative, right? You can see the origin here as well. Statistics. So x is from 600 to 8, nearly 900, 23 to 800. It's a bit inconvenient. So LuBan has a convenient function for you to zero xy. When you zero it, you see clearly on the axis the rough size about this model. It won't start from a negative value or a positive value. It will start from 0. When you have these pre-steps to prepare the model, you are ready to do the hollow. You can hollow by 10. This is a half meter tall model, so 10 is a reasonable value. Okay, when the hollow model is calculated, you can cut into it. Nicely done. Okay, then you can use the modular cut method to cut the model into pieces. I will not do that on the cow model because I know the original model has defects. The tail intersects with the main body, and you can see the intersection here. You can see the intersection here. I know this model has self-intersection defect even on the original solid model, so I won't bother to cut it. If the cutting planes goes through this region, the defect will be exhibited. If the cutting planes happen to not go through these regions, then we are lucky. The resulted part STL will only have self-intersection that pertains in this region and not propagated elsewhere. That is all for this video. Thank you for your attention.